If you're listening to this, there's a good chance you're lying in the dark. Maybe there's a soft glow from a screen, or just the gentle outline of the room around you. Outside, beyond the ceiling, beyond the clouds, beyond the thin blue shell of our atmosphere, space is quietly at work. Asteroid impacts sound like something that belongs to loud movie trailers and flashing warning graphics. Explosions, shock waves, cities vanishing in a single cut. The kind of story that makes your shoulders tense without you noticing. But the real story of asteroids is much slower, much older, and strangely, much more gentle. Tonight we're not here to panic about rocks from the sky. We're here to fall asleep under them, to look up with our mind's eye and understand how these silent visitors have shaped our world and how rare it truly is for them to threaten it. You're safe. The planet is quiet. And this is just a story. Asteroid impacts have always captured the human imagination because they sit at a strange crossroads. They are both incredibly rare and unimaginably powerful. For most of Earth's history, the sky has simply worked. Day follows, night stars drift in their slow patterns, and the planets keep their appointments around the sun. And yet, every so often, something small breaks the pattern. A piece of rock or metal left over from the early construction of the solar system crosses our path. The idea that a single object could reshuffle life on an entire planet is unsettling. But before we think of endings, it's worth remembering this: without impacts there might never have been a beginning. Long before humans, before dinosaurs, before even the first forests, the newborn Earth was a hot, chaotic place. It spun through a crowded solar system full of debris, planetary embryos, shattered fragments, and restless ice and rock. One of those early collisions, a truly colossal one, likely tore a huge chunk from the young Earth. That debris gathered and cooled and became our moon, the pale companion that watches over you each night. Later, countless smaller impacts may have delivered much of the water that now fills our oceans. Piece by piece, icy bodies from the outer reaches of our system fell inward, melted and left their cargo of water behind. The same events that feel destructive to us lying here on the surface were part of the construction of the world beneath us. The story of impacts is not just a story of destruction. It's a story of building, reshaping, and in a strange way, caregiving. Still, you might be thinking of one particular impact. A familiar name, the asteroid that helped end the age of the dinosaurs. Around 66 million years ago, a large object about 10 kilometers across struck the region we now call the Yucatan Peninsula in Mexico. It carved out the Chicxulub crater and unleashed a chain of events that wiped out roughly 3/4 of all species on Earth. For the dinosaurs, it was the closing curtain. For small mammals hiding in the undergrowth, it was the opening of a new stage. Tonight, we don't need to relive the violence of that day. We can simply acknowledge it. A single rock in the right place at the wrong time changed the direction of life. But here is the part your nervous system needs to hear very clearly. Events like that are incredibly rare. Not just once in a lifetime rare. Not just once in a civilization rare. More like once in many, many millions of years rare. In the calm darkness of your room, that timescale is almost impossible to feel. Your heartbeat, your breathing, the ticking of a clock, these are measured in seconds. Mass extinctions unfold on the canvas of millions of years longer than our species has even existed. As you breathe in, you're sharing the present with countless small pieces of space dust that are burning up harmlessly above you. As you breathe out, the cosmic catastrophes that shaped our world sit so far in the past that they might as well be myths carved in stone. Asteroids feel frightening because they seem unpredictable, a bullet from the black. But in reality, the universe follows rules. Orbits are stable, patterns repeat, and over billions of years the solar system has grown quieter. The big, dangerous objects, the ones large enough to threaten our entire civilization, have mostly been swept up, smashed, or locked into safe, stable paths. The longer our solar system lives, the fewer huge bodies remain on wild crossing orbits. And there's something else that's different now, something no dinosaur ever had. We can look. All around the world, telescopes scan the sky night after night, measuring faint points of light and plotting their movements. Astronomers quietly catalogue near-Earth objects, mapping their paths years, even decades into the future. The more we watch, the less surprising the sky becomes. There is a strange sort of comfort in that. The universe hasn't become less powerful, but we've become less blind. If you step back from the fear and the movie scene's asteroid impacts become part of a larger, softer picture Earth as a world shaped by the slow accumulation of small things. Millions of times a day, tiny grains of dust enter our atmosphere. They flash briefly as shooting stars and vanish. Most are no larger than a speck of sand too small to ever reach the ground. Larger pebbles arrive less often, boulder-sized rocks are rarer still, and the truly giant bodies, the ones we make dramatic films about, visit on timescales so long that it is statistically almost impossible for you or your children or their children to ever witness one. The universe can do enormous things, but most of the time it proceeds by gentle accumulation, dust settling on dust, snowflakes falling on snowflakes, impacts that are too small to notice adding up over eons to mountains, basins, oceans and atmospheres. Tonight, as you lie here, your body is resting on rock and soil that has been through all of this. Melted, shattered, compressed and rebuilt. The crust beneath you is a survivor of a 4.5 billion year experiment. You're not fragile glass under a hostile sky. You're part of a planet that has already endured the worst the solar system had to offer and kept going. So when you hear the word asteroid, you don't have to picture sirens and flashing lights. You can picture something else, a quiet dark sky over a sleeping Earth. Tiny grains of dust tracing brief silver lines as they burn away. A few small fragments making it all the way down, landing unnoticed in empty fields and deserts and oceans. Far above them we have learned to watch. We trace the paths of the larger objects with patient care. We run simulations, we plan missions, we rehearse ways to nudge danger aside long before it ever arrives. In the coming parts of this series we'll drift deeper into that story, how we learned to protect ourselves, how a small spacecraft changed the path of a distant rock, and how comets and asteroids may have brought us the water we drink and the building blocks of our own bodies. But for now, you don't need all of that. For now, you can let one simple thought settle in. The sky is vast, the threats are rare, and you are lying on a world that has already survived far more than you will ever have to face. Let your shoulders unclench, let your jaw relax. Listen to your own breathing as another tiny shower of dust burns up high above you, unseen, harmless, and strangely beautiful. You're safe under this quiet ancient rain, and the night is very, very calm. If part 1 was about easing into the quiet of the night, this part is about drifting backward, far backward into a time when Earth wasn't calm at all. A time before oceans, before continents, before any life had ever taken a breath. A time when our planet was still young, glowing and unfinished. It's strange to think about it as you lie there in a peaceful room, your breathing slow, your body settling into the mattress. Because if you were to travel back 4.5 billion years, you wouldn't find anything resembling the world that holds you now. You'd find heat. You'd find darkness lit only by molten rock. And above this fiery newborn Earth, you'd find a sky crowded with wandering bodies, shards of rock and metal left over from the solar system's creation. Tonight we're going to float through that ancient chaos, but softly, like a quiet retelling of a very old story about how struggle and collisions eventually made room for life. Theia, the planet. That almost was long. Long ago, there were more worlds in our solar system than there are today. Some were small, some were large, and one of them may have been about the size of Mars. We call it Theia. For millions of years, Theia orbited close to the young Earth, 2 worlds circling the Sun like partners in a slow cosmic dance. But their paths weren't stable. Gravity tugged and nudged like 2 dancers whose steps were just slightly out of rhythm. Eventually, the gentle drift became an unavoidable meeting. You might imagine a violent explosion sound fire shock waves, but in the vacuum of space, everything is silent. The collision was enormous, yes, but also strangely quiet. 2 worlds touching, merging, breaking apart with no air to carry a single sound. Theia struck Earth off-center. The impact tore away huge amounts of the young planet's outer layers, flinging molten rock into orbit. For a brief moment, only minutes, Earth had a glowing ring not unlike the early stages of Saturn's rings made of incandescent debris. And from that ring slowly something gathered. Clumps became boulders. Boulders became mountains drifting through the dark. And gravity pulled them together until one object dominated all the rest. Our moon was born. Tonight you lie under its pale light, a silent witness to one of the greatest collisions in the history of our planet. It feels timeless and gentle now, but its origin was forged in a moment of unimaginable force. Yet without that force, nights would be darker. Tides would be almost non-existent. Earth's spin would wobble unpredictably. Life might never have found a stable foothold. What feels calm above you tonight was once chaos, and that chaos carved out the stability we depend on, a planet tempered by impacts. After Thayer's collision, Earth didn't immediately become the serene blue world we see in photographs. For hundreds of millions of years it remained molten, a restless ocean of magma hardening and melting again and again as the sky rained debris. Large impacts punched deep into Earth's surface, stirring its interior and helping shape the core and crust. Smaller bodies added ingredients, metals, minerals, and most importantly water. The idea that our oceans may have arrived from space is one of the most humbling thoughts in planetary science. It makes every wave, every raindrop, every river feel a little more mysterious. Imagine tiny icy asteroids called carbonaceous chondrites, drifting in from the cold outer regions of the solar system, each one carrying frozen water carbon molecules and traces of hydrogen isotopes. When they struck Earth's hot surface, they vaporized, instantly releasing their water into the atmosphere where it eventually cooled, condensed, and fell back down as rain. Not just a gentle drizzle, more like rain that lasted millions of years. Drop by drop, impact by impact, the oceans filled, and somewhere in that slowly forming water, the chemistry of life began its first quiet experiments. Violence as a sculptor, not a destroyer. It's natural to think of collisions as destructive as is vents that break things apart. But in the infancy of a planet, impacts play a different role. They sculpt, they deliver ingredients, they stir a world that is still too hot, too raw, too unbalanced. Think of a bell that needs to be shaped by repeated strikes, or a seed that requires fire to open. Creation often hides inside moments of disruption. The early Earth needed to be struck, not crushed, not shattered, but awakened. And when the bombardment finally began to slow, when the solar system settled into something more orderly, Earth had become a place capable of supporting oceans, continents, and eventually living things. The chaos outside faded, the surface cooled, and for the first time the world became calm enough for life to take a breath. Tonight it's quiet. As you lie there now, the contrast couldn't be greater. The early Earth glowed like a forge. The Earth beneath you now cools only in the quiet rhythm of night and day. The world you experience with oceans, clouds, trees, cities, and sleeping rooms has its roots in collisions so ancient we can barely imagine them. Yet those collisions are part of you. The calcium in your bones, the iron in your blood, the water in every cell of your body, all of it was shaped or delivered by the restless motions of the early solar system. In a way, you carry the memory of those impacts, not consciously, but in the composition of your body and the world that holds you. It's a gentle reminder that even violent beginnings can lead to soft, habitable outcomes, that chaos can give way to calm, and that the quiet earth you rest upon tonight is the final chapter of a very old, very loud story, told now in silence. As you settle deeper into your own stillness, let that thought drift with you. From fire came oceans. From collisions came stability, and from the restless birth of the world came a home where you can lie down, close your eyes, and simply rest. There is a special kind of silence in the geological record, a silence that isn't empty, but full of endings and new beginnings layered gently on top of one another. If you could walk through deep time the way you walk through a library, you'd find certain shelves where the story of life suddenly changes, where familiar characters disappear, where new ones appear, and where entire chapters feel rewritten. Tonight we're going to drift into those quiet shelves, not to relive the drama of catastrophe, but to understand how the Earth writes its history slowly, patiently, with stone as its ink. The Earth remembers everything. Earth is very old, and it has an extraordinary memory. Volcanoes erupt and are forgotten. Storms roar and fade. Civilizations rise and vanish. But the rocks remain layer upon layer, recording moments that were once full of movement and heat, holding them still for millions of years. When scientists read these layers, they see patterns of life flourishing and then thinning. They see fossils abundant in one layer and strangely absent in the next. These transitions are called extinction events, but the word extinction can sound harsher than the reality. Extinctions are turning points, resets in the long evolution of the planet, moments when the direction of life shifts in a new way. They are not just endings, they are transitions. The Great Dying, when life paused, not ended. Long before the dinosaurs, about 252 million years ago, Earth experienced what we now call the Great Dying, the most severe extinction we've ever identified. It erased nearly 90% of marine species and about 70% of life on land. But even here, the story isn't one of sudden violence. This event unfolded over tens of thousands of years, almost unfeelably slow on a human timescale. Climate warmed, oceans acidified, ecosystems strained, and slowly the fabric of life thinned, and yet life persisted. Tiny organisms survived in quiet pockets. From their resilience, the next chapters grew. Forests returned, oceans refilled with new kinds of creatures. Land vertebrates diversified into countless shapes. Stone remembers the thinning, but it also remembers the return. The Chicxulub event. A transition in the story of life. 66 million years ago. Another turning point arrived, one that is familiar to many people, yet often told in a way that focuses only on destruction. It was the end of the Cretaceous period, the final chapter of the Age of Dinosaurs. A 10-kilometer-wide asteroid entered Earth's path and struck the region now known as the Yucatan Peninsula. It carved out a broad basin beneath the sea, a feature we now call the Chicxulub crater, hidden beneath layers of rock and quiet farmland. But if we tell the story softly, we can see it differently. For over 150 million years, dinosaurs had ruled the land. They filled every niche, the forests, the plains, the riversides. Life was vibrant, efficient, confident. And then in a single geological moment, one lineage ended to make space for another. The great reptiles stepped aside, and small mammals, creatures that had lived quietly in the shadows, found the room to flourish. They grew diversified, spread across every continent. One day, millions of years later, their descendants would build cities and libraries and telescopes and would wonder how their story began. The Chicxulub event was not only the end of dinosaurs, it was also the beginning of us. It was a transformation, a door closing so another could open. Other impacts. Other transitions throughout Earth's long story. Many impacts have left subtle marks, not always mass extinctions, but shifts in ecosystems, climates, and evolutionary paths. Some created basins that later became cradles of biodiversity. Some brought rare minerals that shaped the chemistry of early oceans. Some altered habitats in ways that gave new species a chance to thrive. The Earth does not treat impacts as interruptions. It weaves them into its ongoing evolution. Even the scars, the circular basins, the fractured rock become landscapes where life eventually returns. A crater becomes a lake becomes a wetland becomes a forest, and a forest hosts thousands of new forms of life that never would have existed without that ancient moment. Transformation, not tragedy. As you breathe slowly in the dark, you might imagine extinction as a frightening idea. But in the vast timeline of Earth, extinction is part of a natural cycle of renewal. Life expands, then contracts, then finds new shapes to inhabit. The rocks beneath your feet, the sediment under oceans, the cliffs worn by wind, the mountains rising from old seabeds, all hold the memory of worlds that came before your own. And every time life seemed to fade, it returned in a new form, filling the planet with sounds and colours and movement again. There is comfort in that, a kind of reassurance that change even on unimaginable scales does not end the story, it simply turns the page. Tonight, the Earth is quiet, mass extinctions belong to a past so distant that even the continents were in different places. They gave rise to forests, reefs, birds, mammals, and eventually the humans who now lie under warm blankets falling asleep to stories of ancient worlds. What has passed is written in stone, permanent and silent, but what lives now is soft and breathing. You are part of the chapter that came long after the chaos faded, a chapter built by transformation, not by ruin. As you let your eyes grow heavier, you can imagine the Earth turning slowly beneath you, carrying its deep memories quietly, calmly into the next morning. The world has endured everything it needed to endure. Tonight it rests, and so can you. A universe of falling dust. If the earlier parts of our journey explored giant collisions and ancient turning points, this part invites you into something much gentler. Not world-ending impacts, not craters hundreds of miles wide, but something softer, a cosmic rain so delicate that you've lived your entire life under it without ever noticing. Tonight we slow the story down even further. We zoom out from asteroids the size of cities and drift toward grains as small as the ones caught in the folds of your clothes or the corners of the room you're lying in. Because the truth is simple and strangely comforting. Every moment of every day, dust from space settles gently onto Earth. Not loudly, not dangerously, just quietly. You're listening to this under a world that is always collecting the universe one tiny speck at a time. The great continuum of falling things. When people think about objects entering Earth's atmosphere, they picture something dramatic. A fireball streaking across the night sky, a meteorite thumping into the desert, bright trails of light burning through the dark. But the reality is far softer. The universe sends us visitors of every size, from mountain-sized asteroids down to dust so small it could balance on a strand of hair. Most of what reaches us isn't big at all. In fact, almost everything that falls from space is too small for the human eye to ever detect. Imagine holding out your hand. Now imagine a speck of dust so tiny it slips through the gaps between your fingerprints without you ever feeling it. That is the scale of the universe's quietest gifts, and Earth receives them constantly. 15,000 tons of cosmic dust every year. It sounds like a lot, but spread across a whole planet, it becomes almost nothing at all, a whisper falling onto a world. Scientists estimate that about 15,000 tons of space dust settle onto Earth every year. Not in one place, not in a single event, just scattered gently across oceans, mountains, forests, and cities, in tiny, nearly weightless pieces. Each speck might come from the tail of a passing comet, from the slow erosion of asteroids, or from debris left behind by the early solar system, long before Earth ever had oceans or air. Some particles drift downward like invisible snow. Others burn faintly in the upper atmosphere, too small to create a noticeable streak of light reduced to ash that settles through the sky one molecule at a time. And every night as you breathe in and out, the planet quietly collects a little more of the cosmos. Dust as an ancient storyteller. These tiny grains are more than just particles. They are fragments of things older than Earth itself, older than the moon, older than our oceans, older than life. Some of them contain minerals that formed before the sun ignited. Some travelled for millions of years before meeting our atmosphere and falling gently into it. A few might be older than any rock that exists on our planet. They're like the universe, leaving us notes, small silent reminders that Earth is not alone, that we live in the middle of a vast system, where everything is slowly exchanging matter quietly, constantly. When researchers collect cosmic dust from Antarctic snow or ancient ocean bed sediments, they are reading the universe's diary one grain at a time. A gentle rain. We never feel. You may have seen shooting stars, bright quick flashes in the night. But for each visible meteor, millions of invisible motes fall unnoticed. Imagine that a soft rain that touches everything and harms nothing. It lands on rooftops, on silent forests, on deep ocean surfaces far from any human presence. It settles on car windows, city streets, and the petals of flowers that will open with the morning light. It even falls on people, on your clothes, your hair, your outstretched hands, though it's far too fine to ever feel. This cosmic dust will never carve craters, never destroy cities, never disturb the night you're lying in. Its only presence is a quiet one, the calm reality of a falling sky. Many people imagine space as hostile, chaotic, dangerous. Meteor showers, asteroids, comets, all these words feel dramatic. But when you understand the continuum of sizes from giant rocks that strike once in tens of millions of years down to the dust that falls every second, you begin to see a much gentler pattern. Earth is not under attack. Earth is participating in a slow, ancient exchange with the rest of the solar system. Big impacts shaped our past. Tiny particles shape our present. The sky is not a source of fear, but a source of constant quiet connection. Tonight, you lie under a soft cosmic blanket. Even now, as your eyes grow heavier and the world around you becomes softer, dust from distant stars is drifting downward. Not toward you, specifically, just toward Earth. Toward everyone and everything. It will land silently in the dark, becoming part of the soil, part of the oceans, part of the world that will greet you when you wake. And in that thought there is a kind of peace. The universe does not only send giant catastrophes. Most of the time it sends something gentler, a whisper of its presence falling slowly, harmlessly onto a resting planet. So breathe in, breathe out, and let yourself feel how quiet the cosmos really is. A universe of falling dust and you safe beneath it. 25 million visitors per day. You've probably seen one at some point, a fast bright streak cutting across the night sky, gone almost as soon as your eyes catch it. A shooting star, a meteor. A tiny visitor from somewhere far beyond the calm air surrounding your room. They feel rare, special, a moment you might wish on. But the truth is far more magical. Earth welcomes around 25 million of these visitors every day. Not one, not 100, not even 1,000. 25 million every single day. And almost all of them are so small, so delicate, and so gentle. that nobody ever sees them arrive. Tonight we'll drift into this quiet migration, a soft, constant ballet of particles falling toward Earth, burning away in silence, never touching the ground. A planet under gentle fireworks. When people imagine meteors, they often think of dramatic fireballs, bright, loud, cinematic. But most meteors are not big. In fact, the vast majority are smaller than a grain of sand. Many are dust-sized lighter than the tiniest seeds that float on the wind. Picture a bit of ash rising from a candle flame. Picture something even lighter. That is closer to the true size of most meteoroids entering our atmosphere. And yet, when these tiny grains hit Earth's upper air at tremendous speeds, they burn brightly enough to become sparks of light. A whole universe of microscopic embers briefly igniting against the backdrop of deep space. But only a handful grow bright enough for human eyes to notice. Most remain invisible except to the atmosphere that gently receives them. Why they burn up. A soft explanation. When a speck of cosmic dust enters Earth's atmosphere, it's travelling astonishingly fast, tens of thousands of kilometers per hour. But the burn isn't caused by friction, in the way we think about rubbing hands together. It's something gentler and more poetic compression. The meteoroid forces air molecules to pile up in front of it, squeezing them tightly. Compressed air heats up. It's the same principle that warms a bicycle pump when you use it. That heat glows, the meteoroid glows, and in a brief, beautiful moment it becomes a shooting star. Nothing explodes, nothing crashes. It simply warms, brightens, then dissolves into the air like breath on a cold morning. Almost none of these visitors survive their journey. They return to dust the same way they began, tiny sparks from a vast sky. Even though you don't see most of them, your world is surrounded by these tiny flashes. Picture the sky above you, dark, quiet, still. Now imagine that every single minute hundreds of invisible streaks are happening somewhere overhead. Only the brightest manage to reach your eyes, a meteor like a silver brushstroke across the stars. Meteor showers like the Perseids or the Leonids aren't storms of big rocks. They're simply times when Earth drifts through a cloud of ancient comet dust, a river of tiny particles trailing behind a comet that passed centuries or millennia ago. Every streak you've ever seen was once part of something older and larger, softly returning to space as light. Not danger, but connection. It's natural to think of things falling from space as frightening. But these meteors aren't threats. They're phenomena so delicate that the atmosphere protects us from them every single moment. Earth is wrapped in 100 kilometers of air, a blanket that turns nearly all cosmic particles into soft flashes long before they approach the ground. Those shimmering streaks in the sky aren't danger at all. They are proof that the planet is doing what it has always done, guarding life with a shield of air thicker than any armor humans could build. The meteors don't break that shield. They simply glide into it, flare briefly and fade. You live on a protected world. Visitors from everywhere. These tiny meteoroids come from many places. Fragments chipped off asteroids, dust from comets shedding their icy surfaces, particles from long-destroyed worlds, grains older than the sun itself. Each one has its own story. Some travelled for thousands of years, some for millions, some for billions. And then by chance they reached Earth, a tiny blue sphere gliding through space. They arrived with no sound, no impact, no harm, just a moment of light before becoming one with the air. A night sky full of wishes. If you were to lie outside under a truly dark sky away from city lights, your eyes adapted, your breath slow, you might see one meteor every few minutes. One small visitor out of 25 million. Each streak you do see is a gift of timing. Your eyes open at the exact moment a grain of cosmic dust finishes its long journey. It's almost as if the universe whispers very quietly, "Look, tonight they fall as you sleep." Even now, as you're listening to this soft narration, meteors are falling above you. Tiny flashes too faint to notice. Particles dissolving upward in the atmosphere long before they would ever reach the ground. You're lying under a gentle, constant firework display, a show that the planet has been watching for billions of years. It asks nothing of you. It threatens nothing. It simply happens invisibly beautifully all the time. As you breathe in and breathe out, you can imagine these faint sparks drifting overhead, the quiet arrival of visitors you'll never meet. Just 25 million tiny stories ending in the same peaceful way. Let your mind soften with the thought that Earth is always receiving the universe not with violence, but but with warmth turning dust into light and light into silence. A sky full of invisible shooting stars and you resting safely beneath every single one. Fireballs and close calls. Up until now, our journey has moved through quiet things. Dust falling through the atmosphere, tiny meteors burning away in silence. But every so often, a slightly larger visitor arrives. Still small on a cosmic scale, but large enough that we notice it. A little brighter, a little louder. A reminder that the sky is active even if the earth beneath us feels still. Tonight we're going to revisit one of these rare moments, not in a dramatic way, but in a soft human way. A story of surprise, not catastrophe. A story of resilience, not fear. It begins on a cold morning over the Ural Mountains in Russia, a winter sky and an unexpected visitor. On February 15th, 2013, as people in the city of Chelyabinsk prepared for their day, students heading to school, office workers stepping out into the frost drivers, warming their cars, a bright object appeared high above them. It wasn't large, about 20 meters across, small compared to the giant asteroids that shaped Earth's ancient past. But it was moving faster than any jet, faster than any sound the sky could carry. The sunlight touched it and it flared white. A fireball, a meteor brighter than the morning sun. For many people it lasted only a moment, a brief beautiful flash arcing across the blue sky. Some thought it was a missile, others thought it was a plane. Others simply paused, watching it silently as they held their morning coffee. The gentle science behind the flash. What happened next wasn't an explosion in the usual sense. It was the air itself, compressed, squeezed, heated, responding to an object moving impossibly fast. Just like tiny meteors burn from compression, larger ones sometimes break apart in the upper atmosphere. They fragment softly at first, then more rapidly until the stress becomes too much and the body tears itself into pieces. Far above the ground, the Chelyabinsk meteor broke apart, releasing energy into the air. Not into the city, not into the ground, into the sky. A wave of pressure travelled outward, strong enough to rattle windows and in some cases break them. It startled people, it scared some, it injured many, mostly from shattered glass as they moved toward their windows to look at the bright streak. But what matters most is this: no one died. Not one person. Humanity endured a once-in-a-century event and walked away, meaning in a moment of light. In the hours that followed, videos spread across the internet, dashcam footage, security cameras, home recordings of the sky lighting up in a place where nothing unusual was expected. For scientists, these videos became a treasure, hundreds of angles allowing them to reconstruct the meteor's path with extraordinary precision. But for people in Chelyabinsk, the moment became something different, a shared experience. A story told over tea, over dinner, over phone calls to friends far away. A reminder that surprises can come from the sky, even in the middle of an ordinary morning. And yet the world didn't end. Life continued. Schools reopened, buildings were repaired. The city healed quickly with a resilience that felt almost ordinary. Why such events are rare? It's important to understand how unusual Chelyabinsk was. Asteroids that size hit Earth maybe once every century. Often they fall over oceans, deserts, or remote forests where no one ever sees them. Most burn up entirely. Most never make the news. Most fall in silence the way everything else in the sky does. Earth is enormous and humans occupy only a tiny fraction of its surface. The idea of a meteor arriving over a populated city is already rare. The idea of one causing real devastation is rarer still. And now we've built better systems, more telescopes, more sky surveys, more simulations, more awareness. Each year the unknown becomes smaller, the sky becomes less surprising. We are learning, we are watching, we are prepared. Humanity's quiet strength. What happened in Chelyabinsk could have been frightening, and for many in the moment it was. But the story that stays with us isn't fear, it's resilience. People helped one another. Parents held their children close. Communities cleaned up shattered glass and patched broken walls with steady, patient hands. The Earth absorbed the event as it has absorbed countless others. Humanity did the same. We are softer than the cosmos, but also more adaptable, more inventive, more connected. A single unexpected flash did not overwhelm us. It simply reminded us how rare such moments are and how well we endure them when they happen. Tonight, the sky is calm as you lie here listening. The night outside is peaceful. The atmosphere, Earth's protective blanket, is still doing what it has always done, softening the arrival of cosmic visitors, breaking them apart, turning them into harmless flashes far above your head. Chelyabinsk was dramatic only because we noticed it. Most events like it pass unseen over oceans and mountains without ever touching human life. You're safe under this sky. The planet is quiet, and the universe, despite its size and power, rarely sends anything harmful our way. Let the thoughts settle in you like a slow exhale. Even when the sky surprises us, we endure. Even when fireballs appear without warning, they fade long before they reach us. And even when the cosmos is active, it is mostly gentle. Rest in the certainty that harmful events are rare, humans are resilient, and the night above you is peaceful once again. Mapping the skies. Our modern watchtowers. If the stories of ancient impacts remind us how powerful the cosmos can be, our own age offers something gentler, the comfort of awareness. For the first time in Earth's long history, one species is not only watching the sky, but mapping it with patience, care, and quiet determination. Across deserts, mountaintops, and islands, under clear dark skies, far from city lights sit our modern watchtowers, telescopes that never sleep, listening for faint glimmers of motion among the stars. They sweep the heavens night after night, not in fear but in curiosity, drawing slow, precise lines through the darkness, turning moving dots into orbits and orbits into knowledge, a calm global vigil. We often imagine science as loud rockets, engines, bright laboratories, but asteroid detection is a soft science, a quiet discipline. Observatories in Arizona, Hawaii, Chile, the Canary Islands, Australia, and places even more remote coordinate their nightly watch. Each telescope contributes a few careful measurements, an arc of motion, a brightness change, a tiny streak in a photograph just a few seconds long. From these whispers, scientists reconstruct entire journeys, paths traced across millions of kilometers. They can tell where an asteroid has been and where it will go for decades, sometimes centuries into the future. It's a gentle kind of guardianship built on mathematics, patience, and long quiet nights. 20,000 discoveries and counting. In just the past 2 decades, we've discovered more than 20,000 near-Earth asteroids. Every week, another handful is found, about 30 new discoveries, added steadily like beads on a string. Most of them are harmless, passing quietly through the inner solar system on predictable, easygoing orbits. Some never come close to Earth at all. Some drift past us once, and then wander away forever, silent travelers whose paths we now understand. With each new discovery, our picture of the solar system becomes clearer, more complete, more comforting. The unknown sky grows smaller, the surprises grow fewer, and the future becomes easier to predict. The reassuring reality. There is something soothing in realizing just how thoroughly we watch the heavens now. Nothing large can approach Earth without being noticed long in advance. Even medium-sized asteroids, the kind that could affect a region, are increasingly catalogued, tracked, and understood. Every dot on a scientist's screen is another reminder that uncertainty is shrinking. The cosmos hasn't changed, but our ability to see it has, and that sight brings reassurance. A planet no longer in the dark. For billions of years, Earth lived beneath an unobserved sky, meteors and comets arriving without witness and without warning. But now, for the first time in Earth's story, we are looking upward with intention. We're not powerless wanderers anymore. We're active participants in our planet's safety caretakers who understand enough to protect what we cherish. That truth settles gently like starlight on a calm ocean. We are watching the sky carefully. We are learning faster than ever, and the night above us is no longer unknown. Let that awareness ease your breath as you rest, a reminder that you are living in an era when humanity keeps a gentle, steady vigil over the heavens. If we found one coming, imagine just for a moment a quiet evening somewhere on Earth. A telescope sweeps across the sky just as it does every night. The air is still, the stars are steady, and on a computer screen a tiny point of light appears, moving ever so slightly against the backdrop of eternity. A new asteroid, one more visitor among thousands. Most of the time these discoveries are routine, filed away into charts and catalogues, their orbits, harmless and familiar. But suppose in this soft thought experiment astronomers follow its path, and the numbers whisper something unusual. Not danger, not panic, just a small possibility that this one might be headed a little too close to Earth many years from now. What then? Tonight we explore that idea gently, not as a warning, but as a story of preparation and calm capability. A quiet scenario, not a crisis. If such an asteroid were ever found, the first reaction wouldn't be alarms or headlines. It would be computation. Dozens of observatories would take more measurements. The asteroid's orbit would be refined, its future path smoothed out with increasing clarity. The vast majority of the time, what looks worrisome at first becomes perfectly safe once the math settles in. And in the rare case where the path still looks too close, we would have time, years, decades more likely, time enough to breathe, time enough to think, time enough to adjust its path without ever needing grand heroics. The gentle power of early deflection. Asteroids, even the large ones, drift through space with patience. A tiny nudge, the smallest touch, can add up over years to move them safely aside. Humanity has explored several ways to give such a nudge. None of them look dramatic. There is no explosion, no flash, no cinematic spectacle. They're quiet technologies built on soft principles of physics, the gravity tractor. A spacecraft could simply fly alongside the asteroid close, but not touching, letting the gentle tug of gravity slowly pull the asteroid's orbit in a different direction. Over years, that tiny pull would shift its path by thousands of kilometers. Sunlight steering mirrors placed on the surface could focus sunlight just enough to warm a patch of rock, creating small jets of gas that act like natural thrusters. The asteroid changes its course using its own breath, a delicate orchestration of heat and motion. Slow, push, long view. Even metal plates or sails attached to the surface could catch the wind of sunlight, letting radiation pressure guide the asteroid very slowly into a safer orbit. All of these methods share one idea: we don't need force. We need time. A gentle push applied early is all it takes. The understanding behind the calm. We imagine asteroids as unstoppable, but the truth is that they are among the easiest objects in the solar system to influence. They are small. They are slow in cosmic terms. Their paths are predictable. And if we ever discovered one headed our way years ahead of time, we could act with the same quiet precision with which we discovered it. The sky does not drop surprises without leaving long shadows first, and we have learned how to read those shadows, drifting toward reassurance. So if someday a tiny point of light on a screen hinted at a future encounter, the story would still be a gentle one. It would begin with care, continue with calculation, and move toward a slow, thoughtful plan to guide the asteroid safely past our world. No panic, no rushing, just a patient partnership between Earth and the people watching over it. Because knowing what comes from the sky gives us the ability to quietly reshape the future long before anything ever reaches us. And in that idea there is a comforting truth. If we ever found an asteroid coming, we would have the time, the tools, and the calm clarity to guide it away. The first ideas. Gravity mirrors and light. We often imagine planetary defense as something loud and dramatic: rockets, explosions, urgent countdowns. But in reality, the earliest ideas for protecting Earth were almost the opposite. They were quiet concepts, slow concepts, elegant, gentle nudges rather than forceful blows. Tonight we drift through three of them, three early visions of how humans might calmly guide an asteroid away from our world, using patience, gravity, and the soft pressure of sunlight. No panic, no spectacle, just physics whispered into motion. The gravity tractor, moving nothing by doing almost nothing. The idea sounds strange at first, a spacecraft that doesn't touch the asteroid at all, yet slowly moves it. Imagine a spacecraft hovering beside an asteroid, matching its speed, keeping a steady distance like a quiet companion walking beside you on a long road. Even though the spacecraft is tiny compared to the asteroid, both objects still feel each other's gravity. Their masses pull together with an incredibly soft force, gentle as a sigh but constant. If the craft maintains its position just ahead of the asteroid's path, its gravity tugs the asteroid toward it ever so slightly. Not miles, not even meters, just centimeters at first. But over years, those centimeters accumulate into a shift big enough to slide the asteroid's orbit safely away from Earth. No impact, no blast, only the quiet pull of companionship in space. The nuclear misconception. Why blowing it up isn't the answer. Movies have given us a dramatic image. A team, a rocket, an explosion that shatters an asteroid into harmless pieces. But the physics tells a softer truth. Asteroids are not solid steel balls. They're loosely bound rubble piles, dust, gravel, and rock held together mostly by gravity. If you were to blow one up, you wouldn't eliminate the threat. You'd likely turn one large object into many smaller ones, all still moving in the same direction, a scatter of fragments instead of a single stone, a cosmic shotgun instead of a cosmic pebble. and many of those fragments would still be large enough to cause regional damage if they reached Earth. So while nuclear devices do have roles in certain rare scenarios blowing up, the asteroid is not our first choice nor our second. Gentler, quieter methods serve us much better. Mirrors and sunlight, steering with warmth. Another early idea sounds almost poetic, using sunlight itself to guide an asteroid away. Some asteroids behave a bit like comets. When warmed by the sun, they can release tiny jets of gas outgassing. It's called that act like small thrusters. If a spacecraft arrived with large reflective mirrors and focused sunlight onto a specific part of the asteroid, it could create controlled outgassing. The asteroid would in a sense move itself, not abruptly, not dangerously, just a steady patient drift as warm gas escapes and nudges the rock onto a safer path. It is celestial gardening, encouraging a natural process to grow in a specific direction. The common thread: time, not force. Each of these early ideas shares a single quiet principle. Small forces applied early are more effective than large forces applied late. A tractor's gravity, a mirror's warmth. Even the subtle push of sunlight acting on a reflective surface, each one builds momentum slowly, carefully, reliably. And because we now watch the skies so attentively, we would almost certainly spot a potential threat years or decades before it could reach us. That time is our greatest strength. It turns gentle ideas into powerful solutions, soft possibilities in a vast sky. These early concepts remind us that planetary defense isn't really a story of violence or urgency. It's a story of foresight, knowledge, and graceful engineering. Moving a mountain-sized rock with gravity mirrors and sunlight sounds like a fairy tale, yet the physics is real, simple, and quietly reassuring. As you lie here tonight, letting your breath slow, remember this. The universe is vast, but so is human creativity. And sometimes the gentlest ideas are the ones that keep us safe. The simplicity of kinetic nudges. For all the imaginative ideas humanity has explored, gravity tractors, mirrored sunlight, delicate steering through warmth and patience, the solution that arrived first turned out to be something beautifully simple. A gentle push, not an explosion, not a dramatic shove, just a small spacecraft touching an asteroid at the right moment, with just the right speed nudging it ever so slightly onto a safer path. This is the heart of the DART mission. A quiet experiment in the quietest corner of our solar system, meant to show that sometimes the simplest gesture can change the entire story. A push, not a punch. When most people hear kinetic impact, they picture something violent, a smashing, a demolishing, a cosmic collision. But the DART concept was never about force, it was about timing. If you push a door gently while it's still almost closed, the smallest touch can guide it to open. But if you wait until the last possible second, you'd need your whole weight to move it at all. Asteroids work the same way. A tiny nudge delivered years before an encounter can shift an asteroid's path by thousands of kilometers over time. And so the idea emerged: send a small spacecraft to tap an asteroid like one pebble, brushing another in a vast, silent desert. A tap so small you'd miss it if you weren't looking for it, yet powerful enough over distance and time to matter. The elegance of kinetic deflection. The concept is almost soothing in its straightforwardness. A spacecraft guided quietly across millions of miles using nothing more than sunlight and ion thrusters approaches a tiny moonlet orbiting a larger asteroid. No dramatics, no fireworks, just steady navigation minute by minute. At the final moment, the spacecraft aligns itself and touches the asteroid at a gentle, controlled angle. The energy it carries is absorbed into the asteroid's motion, a small transfer like tapping the bumper of a massive, slowly rolling car. Most of the asteroid doesn't move much at all, but over months, then years, that tiny shift widens, becoming a meaningful change in the asteroid's orbit. A soft action with a far-reaching consequence. Why? This approach feels so human. In a way, kinetic nudging reflects something familiar about how we solve problems. We move gradually, we adjust, we use the smallest force necessary to guide things where they need to go. It is patient, it is humble, it is thoughtful. Just as one person can steer a boat with the slightest pressure on the rudder, so can a spacecraft steer an asteroid with the softest of touches. It is a reminder that solutions don't need to be loud to be effective, a gentle answer to a grand question. For years, scientists wondered whether a kinetic nudge could truly make a difference. Could such a tiny spacecraft influence a mountain of rock floating in the dark? The DART mission would soon provide that answer. But before we get there, it's enough for now to rest with the concept itself. A simple idea delivered with calm precision. If an asteroid ever wandered too near, we could reach out and guide it away with nothing more than a gentle push. A quiet solution in a quiet universe. Choosing Dimorphos a safe practice target. When the idea of a gentle kinetic nudge moved from theory into reality, the first question scientists had to answer was surprisingly simple. Where do we practice? If humanity was going to test the quiet power of a spacecraft's touch, it needed to find a place in the solar system where that experiment would be meaningful and completely safe. And in the vast catalogue of rocks, fragments and wanderers, one system stood out, a small pair of asteroids circling each other in darkness like two slow dancers in a cosmic waltz. Didymos and Dimorphos, a binary pair in the quiet. Imagine a parent and a child walking in a circle hand in hand. The parent takes broad steps, the child tiny ones, but both remain bound together. That is the Didymos system. Didymos, the larger asteroid, is about 780 meters wide, big enough to be recognizable, but small enough to be safely influenced. Dimorphos, the moonlet, is just 160 meters across a little lump of loose rock, orbiting Didymos every 11.9 hours, keeping roughly 1 kilometer of distance between the two. They circle the Sun together every 2.1 Earth years on a predictable, stable path that has never posed a threat to our planet. They are in many ways a peaceful pair, unassuming and quiet, perfect for a practice test. Why a binary system? Was ideal scientists chose this duo not just for safety but for clarity. If DART nudged Dimorphos, the easiest way to detect success would be to watch how its orbit around Didymos changed. That orbital period, 11 hours 55 minutes before the test, acts like a built-in clock. A clock that nature itself set and that scientists could read from millions of kilometers away. If the orbit shortened even slightly, it would mean the nudge worked. No guesswork, no ambiguity, just the clean, simple mathematics of one body circling another, a cosmic laboratory. Close enough to reach far enough to be safe. The Didymos-Dimorphos system made a close approach to Earth in 2022, passing within 10.6 million kilometers, far, far away in everyday terms, but comfortably reachable for a spacecraft designed for patience. It was distant enough that no matter what happened, even if Dimorphos were pushed far more than expected, the system could not be shifted onto a path toward Earth. Every scenario, every model, every calculation confirmed the same reassuring truth. There was no risk, not even the faintest chance. This was practice, nothing more. A quiet rehearsal for a future we may never need, but one it is comforting to prepare for. A rubble pile, gentle by nature. Another important detail. Dimorphos is not a solid rock. It is a rubble pile, a loose collection of stones, dust, and early solar system fragments, held together mostly by gravity. This made it ideal for studying how such objects react to gentle impacts, how much momentum is transferred, how much dust is released. How does a loosely packed asteroid respond to a subtle push? Dimorphos offered answers not available anywhere else. Soft material, soft physics, a perfect match for a gentle mission. Why Dimorphos was the right first step. In the end, the choice of Dimorphos wasn't just a technical decision, it was symbolic. A small, quiet world circling its partner in an endless loop, untouched, unthreatening, and patient enough to let us learn. If humanity wanted to test its ability to guide an asteroid, why not begin with a place already shaped by slow motion and soft gravitational ties? And so Dimorphos became the first asteroid in history to receive a purposeful nudge from Earth, not as an act of force, but as an act of understanding. Because even in planetary defense, our first step was a gentle one, building DART a refrigerator-sized guardian, before DART became a streak of motion in the dark. Before it crossed millions of kilometers and touched a tiny moonlet, it began as something much more humble, a small boxy spacecraft barely larger than a home refrigerator. No towering rocket stages attached, no complicated arms or drills, no dramatic sci-fi machinery. Just a compact guardian built with quiet purpose and thoughtful simplicity. Tonight we open its doors gently and look inside. A spacecraft built on the beauty of enough. Many spacecraft are marvels of complexity. DART was almost the opposite, a craft shaped by restraint. Its engineers designed it to do one thing well: navigate across space and softly impact Dimorphos at precisely the right spot. So instead of layers of instruments, DART carried only what it truly needed: a sturdy body. Solar panels to gather light, gentle electric iron thrusters, a single camera for navigation, a radio antenna to whisper updates home. Every component had a purpose. Nothing extra, nothing loud. It was a lesson in engineering calmness. When a mission's goal is clear, the design becomes almost peaceful. Draco, the one eye that saw everything. DART had only one camera, but it was remarkable. Its name was Draco, the Didymos Reconnaissance and Asteroid Camera for optical navigation. Not a flashy instrument, not even especially large, just a quiet, dependable observer built to guide the spacecraft through its entire journey. Draco had to do three things: see the asteroid from millions of kilometers away as a tiny bright point in blackness, distinguish Dimorphos from Didymos as the spacecraft approached a difficult task like spotting a pebble orbiting a boulder in deep shadow, steer DART in its final moments with perfect accuracy, because once the spacecraft began its terminal approach, there would be no commands from Earth, only trust in Draco and the software guiding it. This single camera became DART's brain, its compass, and its final witness. Autonomous navigation, a quiet piloting system. In the last hours before impact, Earth was too far away for real-time control. Radio signals take minutes to cross the distance, far too slow for precise steering, so DART flew itself. Its navigation system, called SmartyNav, was trained to identify Didymos, lock onto Dimorphos, ignore distractions, adjust its path gently, focus on the moonlet, stay centered, stay calm. As it got closer, the system updated its own instructions every second, making subtle corrections like a careful hand guiding a thread through the eye of a needle. No human pilot, no joystick, no emergency override. Just a small spacecraft with quiet confidence, following the path it had prepared for years. Lycia Cube, the little witness. DART did not travel alone. Trailing behind like a tiny companion on a long journey was a suitcase-sized Italian spacecraft named Lycia Cube. It separated from DART 15 days before impact and maneuvered itself into the perfect vantage point to watch the encounter unfold. Its job was simple and beautiful: to witness DART's moment of contact and send images home of the dust, the motion, and the changes that followed. While DART gave the gentle push, Lycia Cube provided the eyes that would show the world what that push accomplished. A duet of purpose, one spacecraft touching destiny, the other recording it. Why DART's simplicity was its strength. In a universe full of uncertainty, DART's design offered a quiet reassurance. You don't need something enormous to make a meaningful difference. You don't need a fleet. You don't need explosions. You don't need grand machinery. Sometimes all you need is a well-built little guardian, a single camera, a patient navigation system, and a companion watching from behind. A refrigerator-sized spacecraft carrying a single idea across millions of kilometers. A small nudge today can mean safety tomorrow. As you rest tonight, you can imagine DART drifting through space. Not loud, not dramatic, just steady, determined, and beautifully simple. A reminder that gentle engineering, like gentle force, can guide worlds. The 10-month journey. Before the world ever saw images of Dimorphos, before the final approach, before the quiet tap that changed its orbit, DART had to make a long, patient journey, 10 months drifting through deep space with no sound, no hurry, and nothing but the slow dance of sunlight to guide its wings. Tonight we travel alongside it, not with excitement, but with the soft, reflective calm that filled the mission from the start. A gentle beginning, the launch. It began in November of 2021 on a cool night at Vandenberg Space Force Base in California. There was light, and there was waiting, and then a deep rising rumble. But even here there was no drama, no frantic countdown. Just a steady ascent as the Falcon 9 booster lifted DART into the quiet dark above the Earth. The moment the spacecraft separated, a kind of stillness settled in. The rocket fell away. The noise dissolved. Radiation, dust, and silence became DART's new companions. Its solar panels unfolded like wings catching the sun's rays, not for power alone, but for warmth, navigation, and a steady hand through the long months ahead. Cruising through the quiet deep space cruise is not a fast phase. It's not even a busy one. It is a period of long unbroken quiet, a spacecraft gliding through a vacuum so vast that nothing moves unless you ask it to. During these months, DART practiced its navigation systems like someone rehearsing a dance they would perform only once. It aimed its antenna toward distant Earth and whispered small updates home, its location, its health, its calm progress through the emptiness. It was a steady traveller with no need to rush. The Didymos system was not going anywhere, and DART, following its gentle spiral outward, had all the time in the world, small corrections, big patience. Every few weeks, the spacecraft fired its tiny ion thrusters, not in bursts of flame, but with a faint blue glow so delicate that the acceleration was barely noticeable. These adjustments nudged DART toward its target, fine-tuning its path with precision measured in centimeters. The spacecraft moved slowly, but space is wide and slow is enough when you have months to travel and millions of kilometers to cross. These course corrections felt almost like breaths, small, steady, rhythmic. A quiet heartbeat in the dark ocean of space, approaching a pair of shadows. As the months passed, Didymos and Dimorphos grew from invisible to almost invisible, two faint dots still buried in blackness. From millions of kilometers away, they were indistinguishable from the background stars, but DART kept watching. Draco kept staring. The spacecraft's navigation systems kept refining their predictions with quiet confidence. Imagine traveling for nearly a year toward an object smaller than a sports stadium and knowing you must hit it precisely. The poetic beauty of that challenge was matched only by the patience required to meet it. The final week's anticipation in silence. As August 2022 became September, the mood on Earth changed. Astronomers watched, engineers checked and rechecked. The public waited quietly through nightly news updates and gentle curiosity. But in space, nothing was different. DART glided on. Its solar panels caught the same sunlight. Its systems ran the same routines. Its course remained steady. The spacecraft did not feel anticipation. But the people who built it did a kind of soft-measured excitement built on long years of preparation. The impact would not save the world. It was only a test. But it was a test humanity had dreamed of for decades, and now a refrigerator-sized guardian was closing the distance toward a moonlet no spacecraft had ever visited. A soft breath before history. In the last few days, DART began its approach. Dimorphos was still too small to see clearly. Didymos appeared first, a round-turning world slowly sharpening on Draco's camera. Behind it, Dimorphos waited hidden in shadow like a quiet note in a longer song. But this part of the journey, the 10 months of drifting, the peaceful cruise, the steady navigation was already its own quiet triumph. DART had travelled millions of kilometres with one purpose and no hesitation. And now, as the final approach hovered just over the horizon of days, the spacecraft continued forward with the calm, patient certainty that defined its entire mission. A small machine in a vast dark, carrying a gentle idea across unimaginable distance. A reminder that even in space, slow journeys can lead to profound moments. Closing. In a 1-hour countdown. After 10 quiet months and millions of gentle kilometers, the final hour arrived, not with alarms, not with acceleration, but with a shift so subtle you could almost miss it. DART handed control of its destiny to the system designed for this single-moment smart nav, the spacecraft's calm, unblinking pilot. From here on, no human would guide it. No joystick on Earth could steer fast enough. Radio commands would arrive minutes too late, and so DART trusted its own eyes, trusted its camera, trusted its careful algorithms, trusted the quiet intelligence that had been trained to find a single object in a skiffle of darkness. The final hour had begun. Didymos appears a pixel that meant everything. On Draco's screen, Didymos first appeared as a faint dot, just a brighter pixel in a sea of black. 1 pixel, then 2, then a tiny cluster as the spacecraft drew closer. SmartNav watched these pixels with calm precision. It measured their brightness, their shape, their motion. Each second it refined DART's path, a tiny adjustment here, a soft correction there. Nothing rapid, nothing sudden. Just a spacecraft sliding through space with the quiet confidence of something that knows its purpose. Dimorphos emerges from shadow. At first, Dimorphos couldn't be seen. It was hidden against its parent asteroid, a moonlet tucked into shadow like a small stone behind a larger one. But SmartNav knew it should be there. DART had studied this system for years. It knew the orbital rhythm. It knew where the moonlet must appear and when it would drift into Draco's view. And then a faint bump. a soft speck beside the larger asteroid, barely a pebble in the field of vision. SmartNav locked on. That dim cluster of pixels became the target not through emotion or excitement, but through pure clarity. The spacecraft began to ignore Didymos entirely, sliding its path sideways to aim at the smaller moonlet now glowing softly in the corner of the frame. A tiny object 1 billion times smaller than the distance DART had travelled now filled the spacecraft's entire future. Course. Corrections. Like breathing. Every second. SmartNav updated its aim, adjust 1 degree, half a degree, a fraction of a degree small. Motions no larger than the firings of a child's sparkler. Each correction was gentle as breath. The spacecraft's path became smoother and truer with every passing moment. On Earth, scientists watched the stream of images, but they no longer steered. They simply observed a quiet audience to a dance they had choreographed years before. The spacecraft was guiding itself now. 50 minutes. Dimorphos sharpens. With every passing minute, Dimorphos grew clearer, from a single pixel to a soft round blur to something with shape and shadow. You could almost sense the tension of the ancient rock quiet, unknowing turning slowly in the dark as a small visitor approached with purpose. SmartNav adjusted again and again, each motion tiny, barely perceptible, but building toward perfection. In these minutes, navigation became art, a mosaic of decisions drawn from patterns of light on a deep space canvas. 20 minutes. Every rock matters. Now Dimorphos filled the camera frame with real detail boulders, ridges, patches of shadow curving across its surface. SmartNav no longer steered toward a moonlet. It steered toward a point on the moonlet. Pixel by pixel, it chose the exact location, a spot on the sunlit side, where the impact would be clean, clear, scientifically meaningful. Each new frame brought sharper features, a rocky slope, scattered stones, no atmosphere, no sound. Only the rising shape of a small world that had never been seen so closely before. 5 minutes. The world fills the window. Dimorphos now filled Draco's field of view. It was no longer a target, it was a landscape, a horizon, a world. Boulders the size of houses rolled gently toward the edges of the frame. Surface texture sharpened, shadow lines deepened, every pixel carried meaning. SmartNav continued guiding, steady, calm, unflinching. On Earth, scientists grew quiet. They watched as 1 image per second brought Dimorphos closer like beads sliding on a string. 60 seconds. A vision in motion. In the final minute, every frame was breathtaking, a cascade of new details, a surface that had never before been touched by human eyes. Sharp edges, dusty valleys, a field of rocks frozen in time. SmartNav corrected its course 1 last time, then it stopped. The spacecraft had all the information it needed. There was nothing more to compute, nothing more to adjust. For the final seconds, it simply coasted a quiet, steady glide toward a single point on a small asteroid in a vast, silent sky. A refrigerator-sized guardian guided by pixels, light, and purpose. Its long journey now distilled into one final moment of perfect clarity, a flash in the dark. The final seconds of DART's journey did not feel like an ending. They felt like a soft pause, a breath held gently in the space between worlds. Dimorphos filled the camera now, no longer a distant speck or a growing blur, but an entire landscape pressed against the edge of the frame. Boulders the size of cars, shadows frozen in place, ridges that had slept untouched for billions of years. And DART, small and steady, glided toward them with the calm certainty of a leaf drifting toward the ground. No panic, no jolt, no fear, just purpose, quiet and clear. The last images rocks, becoming worlds. Each new frame arrived 1 second after the last, a soft pulse of vision beating across the void. A cluster of smooth stones, a darker patch of dust, a ridge rising like the edge of an ancient hill. Then closer, a large sunlit boulder coming into perfect clarity. Its surface cracked and dimpled from time older than Earth's continents. The images slowed nothing. The spacecraft continued its path unblinking, unwavering. The world that DART had travelled 10 months to meet now rushed gently outward on the screen, as if leaning forward to accept the touch. 5 seconds. A final approach. At 5 seconds, the camera showed texture, not shapes, but grains. Loose rock, fine dust, patterns carved by sunlight and silence. Dimorphos no longer looked like a moonlet. It looked like a quiet ancient place waiting in the cold for its first and only visitor. Dart drifted closer. 4 seconds. 3. 2. The images softened into abstraction, a wash of light and shadow, every pixel filled with more detail than the human brain could process in the moment. 1 second. Touching a world. The final frame arrived, a jumble of rocks so close it could have been beneath your feet, a single boulder filling the view, its edges pale under the distant sun, its surface dotted with dust older than any mountain on Earth. And then nothing. Not a crash, not an explosion, not a shockwave, just silence. Dart disappeared in a flash too fast to see its body absorbed into the asteroid's motion, like a whisper carried off by a quiet breeze. A gentle nudge in a vast universe. Despite what instincts might suggest, the impact was not violent. There was no roar, no plume of fire, no shudder in space. Only a gentle transfer of momentum, the smallest push delivered with perfect timing. Dimorphos barely noticed the touch at first. The dust lifted softly, a cloud of ancient grains floating outward like a sigh released into darkness. Lissacube, watching from behind, captured the moment, a faint flash, a bloom of silver dust, a soft halo expanding in the black of space. The first controlled alteration of a celestial body's orbit in human history, achieved not through force but through grace. The camera goes still. When Draco went dark, the live stream ended not with drama, but with an image of rock only centimeters away. A final still frame of something untouched becoming touched, something ancient meeting something new. It was a peaceful ending to a peaceful mission, a quiet guardian fulfilling its one purpose with precision and gentleness, the afterglow of dust and light. In the minutes that followed, Dimorphos drifted on its dust plume, stretching behind it like a comet's tail, not a scar but a sign that the nudge worked, a sign that humanity could guide a world without harming it, a sign that prevention is often as simple as a steady hand offered early. And so the moment passed, a flash in the dark, a soft breath in the void, a reminder that even in the vastness of cold space, gentle actions can move mountains. Tonight, as you drift into rest, you carry with you the knowledge that our protection does not rely on violence, but on understanding, on small precise gestures made with patience and care, a quiet impact, a gentle nudge, and a universe that keeps turning in silence. 32 minutes that moved. A world. Long after the flash faded and the dust plume drifted away like a pale, expanding veil, Dimorphos continued its quiet orbit around Didymos, steady, unhurried, as if nothing unusual had happened. And for a while, no one on Earth knew exactly what the nudge had done. The spacecraft was gone. The camera was silent. All that remained were telescopes, data, and patience. Night after night, astronomers watched the paired asteroids from observatories around the world: Hawaii, Chile, South Africa, the Canary Islands, listening for the faint rhythm of a moonlet circling its parent in the dark. Before Dart arrived, Dimorphos completed one orbit every 11 hours and 55 minutes. After the impact, everyone expected the change to be small, 73 seconds, barely more than a blink in astronomical time, just enough to prove the concept, just enough to show that a gentle touch could alter a celestial path. But the universe had something more surprising in mind. The first measurements, a soft realization. As the days passed, data trickled in small variations, timing offsets, shifts in brightness, as Dimorphos moved in and out of Didymos' shadow. Something was different, meaningfully different. Slowly the numbers converged. Not 73 seconds, not 2 minutes, not 10, but 32 minutes. A shift 1600% larger than expected. A world had moved more than anyone dared hope, because of a single patient nudge from a refrigerator-sized spacecraft, understanding the magnitude. In space, 32 minutes is enormous. It means the moonlet's orbit was altered by tens of meters every single lap, a shift that compounds over weeks, months, and years. It means Dart didn't just touch Dimorphos, it changed its future. Why was the effect so large? Because Dimorphos is a rubble pile, loose gravel and dust barely held together by gravity. When Dart struck, it didn't only transfer its own momentum, it launched a tail of debris stretching thousands of kilometers behind the moonlet. And as those rocks and grains lifted free into space, they pushed Dimorphos even more the way a boat is nudged forward by the wake of the water it displaces. A gentle impact became a greater movement, because the asteroid reacted like something lighter, softer, more dynamic than anyone imagined. The universe, it turned out, is more responsive than we thought, a quiet achievement, echoing through space. There was no roar when the new orbit was confirmed, no celebration worthy of headlines, just a deep quiet awe shared across observatories and mission rooms. Humanity had moved a world, not with violence but with knowledge, not through desperation but through planning, not at the last moment but long before any danger existed. And the movement wasn't just detectable, it was undeniable. 32 minutes a shift that cannot be missed, misread, or mistaken. It proved that guidance is not only possible, but effective far beyond expectations. A small push from a small spacecraft changed the motion of a body older than Earth's continents, the meaning of the moment. The 32-minute shift was not a spectacle. It didn't change the night sky or ripple through the solar system. It was something softer, a change visible only through calculation and patience, a nudge that echoed not in sound but in certainty. Certainty that humanity can shape its future, certainty that the cosmos is not beyond our touch, certainty that small actions, well timed and well aimed, can alter the course of entire worlds. It was a moment of awe, not loud awe, but the kind that settles deep in your chest, like the quiet recognition that something profound just happened. A world moved, and we moved it. 32 minutes enough time to brew tea, to watch the sunset, to drift towards sleep, but also enough to redefine what is possible. Tonight as you rest, you can hold that thought gently. In a silent corner of space, an ancient moonlet changed its orbit, because humanity reached out not with force but with care, watching the dust dance. Long after the impact, long after Dart had vanished into the quiet body of Dimorphos, a new kind of beauty unfurled in the darkness behind it. A trail of dust, soft, weightless ancient, began to drift outward from the little moonlet, stretching into space like a pale ribbon unspooling in slow motion. And from Earth, telescopes turned their eyes upward to watch the dance, not with urgency, but with wonder. Soar, a gentle sweep across the night. High in the Chilean Andes, the SOAR telescope, a tall silent sentinel, focused its enormous mirror on the Didymos system. What it saw was almost dreamlike. The debris trailing from Dimorphos did not drift away as a cloud, but as a graceful tail stretching thousands of kilometers thinner than smoke, brighter than dusk. Under SOAR's steady gaze, the dust shimmered like threads pulled from starlight. Each particle caught the sun just enough to glow, like embers floating at the edge of a dying fire. And the tail kept growing soft, slow, like a watercolor brushstroke drawn gently across the canvas of deep space. Hubble watches, a moving painting. From orbit, the Hubble Space Telescope looked down with its calm, unblinking eye. Hubble had watched galaxies collide and stars explode, yet even it paused for this small, elegant transformation. It saw two long tails flowing from Dimorphos, delicate streams formed by sunlight and the quiet pressure of the solar wind. They curled and shifted like strands of fog stirred by a breeze that takes centuries to cross a room. Hubble recorded each change, not dramatic, but mesmerizing. A slow drift, a widening arc, a shimmering edge as the dust faintly rearranged itself in the darkness. Time moved differently here, unhurried, soft, as if the universe was stretching after a long sleep. Webb infrared eyes in a silent ocean. Farther away in the deep cold of space, the James Webb Space Telescope opened its golden mirrors toward Dimorphos. Where Hubble saw light, Webb saw warmth, the faint heat of dust grains, the subtle glow of rock fragments expanding outward like petals falling from a cosmic flower. Through Webb's vision, the debris looked like a mist of embers, each one drifting in a path set by sunlight, gravity, momentum, and time. Webb saw the heat of the dust as a soft, spreading whisper, a warm exhale from a moonlet that had slept untouched for billions of years until one gentle visitor brushed against it, the tail that became a comet. Over days and weeks, the dust trail lengthened into something astonishing, a full comet-like tail, stretching 10,000 kilometers. It did not rush. It did not disperse quickly. It simply flowed, following the asteroid pair as they moved through their orbit around the sun. To the telescopes watching from Earth and from orbit, it looked like the gentlest transformation a world can undergo. Not a wound, but a veil light, as breath reflective as frost. A slow ballet between sunlight and stone, a universe that moves softly. There was no sound as the dust drifted outward. No rush of wind, no tremble of motion, just the infinite stillness of space, allowing the tiniest particles to dance freely. Each grain of dust was a storyteller, a piece of Dimorphos letting go, floating, turning, catching faint rays of sunlight that took 8 minutes to reach it. Together they formed patterns so delicate that only the most patient telescopes could perceive them. Curved trails, feathered wisps, shadows moving through shadows. A cosmic snow globe set swirling by a touch so gentle that the moonlet itself barely noticed. A soft reminder. As the dust settled into its long drifting tail, a quiet realization emerged. Dart's impact was not a moment of violence, but a moment of artistry. It revealed how responsive the universe can be, how small actions create large ripples when given time, how even silence can move worlds. And as you rest tonight, you can imagine that tail, faint shimmering, stretching across space, like the trail of a dream slowly dissolving into morning, a reminder that beauty often appears in the smallest motions and the quietest changes. Lysicube's silent flyby. Long after Dart had vanished into the rocky skin of Dimorphos, another traveller glided quietly nearby, small, unassuming and perfectly placed, to witness the moment that no human eye could see. Lysiacube, a companion no larger than a shoebox drifting through the cold dark on patient wings of sunlight. It carried no grand instruments, no powerful arrays, only a pair of gentle cameras and the responsibility of becoming the first witness to a moonlet reborn. As it approached Dimorphos, Lysiacube saw something no spacecraft had ever seen: a newborn cloud of dust spiraling softly into the void. A flyby in absolute silence. In the deep vacuum of space, nothing rustles, nothing stirs. Even motion is silent. Lysiacube circled past Dimorphos like a bird gliding through still air. Its passage unfelt, its presence unnoticed. On board, the cameras flickered to life Leah and Luke's small lenses with gentle sight, and began capturing the slow-moving ballet unfolding in the darkness. Each frame they sent home was a whisper, a soft imprint of a moment millions of miles away. Spirals in the dark. The first images revealed not chaos but grace. Debris curled outward from the asteroid in delicate spirals, loops of dust twisting like strands of silk released underwater. These spirals weren't random, they were shaped by the gravity of Didymos, the moonlet's rotation, and sunlight's subtle push. To Lysiacube's quiet eye, the dust looked alive, a soft drifting breath exhaled by a world that had never before been touched. Tiny stones tumbled outward in gentle arcs, forming trails that curved and stretched like the tails of celestial comets. It was motion born from a single nudge, echoing through space in patterns too delicate for the human mind to invent. The plumes, a cloud of ancient stories. Closer in, Lysiacube saw the plumes, the dense, bright fountains of ejected material that rose from the surface, like slow-motion geysers lit by the distant sun. Each plume was different, one thick and bright, blooming outward like petals of a pale cosmic flower, one faint and wispy stretching into a soft ribbon, swallowed gradually by shadow, one filled with tiny fragments, each piece drifting on its own, but still part of the greater whole. These plumes were the oldest material Dimorphos had ever released, dust and stone that had rested undisturbed for billions of years. And now, freed by a gentle impact, they drifted outward in luminous clouds, catching sunlight as if waking from a long sleep. A landscape transformed. As Lysiacube passed even closer, it glimpsed the surface of Dimorphos itself, a rugged patchwork of boulders and shadows, quietly rearranged by the impact. The moonlet looked unchanged in its overall shape, yet subtly different. A surface brushed a new texture, formed a soft memory of the touch Dart had left behind. There were no scorch marks, no craters like the ones seen on larger worlds. Just a gentle rearrangement, stones shifted, dust lifted patterns reshaped like sand touched by wind. A change visible only to eyes as patient as Lysiacube's. Pulling away. A final look back. As it drifted beyond the system, Lysiacube turned one last time to look back. The Didymos pair were now two small shapes dimly lit, connected by a tail that glowed like ink spread slowly across water. The spirals continued their motion elegant slow, as if the dust itself were dancing its way into the wider cosmos. Lycia Cube's final images captured that dance, a faint blur of beauty, a swirl of ancient rock reborn as drifting light. Then the little spacecraft slipped into deeper darkness, its mission complete, leaving behind a record of soft transformation that no other eye could have seen. A moment kept in dust and silence. There was something mysterious about those images, not frightening, not chaotic, but quietly profound. They showed how a single touch can reshape a world, how dust long settled can rise in spirals and drift like ghosts of ancient stories, how beauty can emerge not from spectacle, but from gentle motion and patient watching. As you drift towards sleep, imagine those spirals slow, weightless, floating forever in a dreamlike arc across the black. A silent flyby, a small witness, a dance of dust seen only once in the history of the universe. Hera, the careful investigator. Long after the dust has finished rising, long after the spirals of debris have stretched into soft fading ribbons behind Dimorphos, a new traveller will make its way to this tiny moonlit patient, deliberate and designed not to push, but to understand. Hera, the European Space Agency's quiet inspector, will launch in 2024 and arrive in 2026, a gentle follow-up to Dart's Touch, a second chapter, written not in motion but in measurement. Where Dart acted, Hera will listen. Where Dart nudged, Hera will study. Where Dart changed a world, Hera will show us how. A mission built on patience, Hera is not a fast spacecraft. It will cross millions of kilometers with a slow, steady cadence, solar panels open, like wings thrusters, whispering softly, instruments resting until the moment they are needed. Its purpose is methodical, to examine the aftermath of a gentle impact with calm scientific care. Nothing about Hera's journey is rushed, nothing is loud. It is a mission built on precision, quiet analysis and the long view, approaching the Didymos system. When Hera arrives at the Didymos Dimorphos system, it will not dive in. It will pause, holding a respectful distance while its instruments orient themselves. Over days and weeks, it will drift closer in small, cautious steps, like someone approaching a fragile sculpture in a museum lit by morning sun. Hera will inspect the system slowly, letting its cameras adjust, letting its sensors acclimate. The first images will show the binary pair against a velvet black backdrop, two quiet worlds still connected by their orbit and by their story. Mapping the crater. The first. Look at the wound. Dart's final frame showed a single boulder seconds before contact, but Hera will see what came afterward. The spacecraft will fly low over Dimorphos, its gentle thrusters, keeping it stable as it photographs the landscape Dart rearranged. It will look for the impact crater, not a violent scar but a shallow depression where stones shifted like pebbles disturbed by a single footstep. Displaced boulders, some moved slightly, some tumbled softly down slopes. Fresh dust, lighter in colour, recently exposed after billions of quiet years. Each piece of evidence is a clue, part of the story, of how a world responds to the gentlest of nudges. Peering inside the interior of a rubble pile. Hera will carry instruments that can sense beneath the surface radar that will pass through Dimorphos's loosely bound interior to reveal what lies within. Is the moonlet solid? Is it hollow in places? Is its core dense or soft as powder snow? These questions matter because the way an asteroid is built determines how it reacts to any future guidance attempt. And Hera, in its slow and steady orbit, will collect those answers, grain by grain, layer by layer. A patient archaeologist in a place without air. Measuring momentum. Understanding how much we moved. One of Hera's quietest jobs is also one of the most important to determine precisely how much momentum Dart transferred to Dimorphos. From Earth we measured the changed orbit 32 minutes gained, but Hera will reveal how that change happened. By mapping the dimensions of the crater, the distribution of ejecta, the mass of displaced material, the reshaping of the moonlet's surface, the full 3D structure of Dimorphos, the spacecraft will help scientists calculate exactly how a small push became such a large shift. It is gentle detective work, not rushing to conclusions, but gathering each small detail until the full picture emerges. A new shape, A new story, Hera, will also measure how Dimorphos itself has changed shape. Asteroids are not rigid. They are malleable in ways that surprise even experts. A gentle impact may have smoothed one ridge, shifted a boulder field, or altered the moonlet's spin by a fraction of a rotation. Tiny changes, but meaningful ones. Under Hera's gaze, these subtle transformations will be mapped carefully, slowly, as if sketching a portrait of a world newly awakened. 2 CubeSats companions on a quiet survey. Hera will not be alone. It will release 2 small satellites, Milani and Juventus, each carrying instruments designed for close-up study. They will drift through the system like careful assistants, collecting data Hera cannot gather from its main orbit: thermal readings, magnetic properties, ultra-close surface images, measurements of interior density. Together, they will create the first complete map of a moonlet changed by human intention, a slow essential mission. Everything about Hera's work will be quiet: its slow orbits, its gentle approach, its patient mapping, its methodical scans. But in that slowness lies profound meaning. Hera is not there to avert danger or to save the world. It is there to learn how we might do so calmly, correctly, and with deep understanding if we ever needed to. Its mission is preparation woven with reflection, a thoughtful study of a moment when humanity moved a world just slightly, just enough, a future shaped by understanding. As Hera circles Dimorphos in 2026, sending home its slow stream of data, it will do more than map a crater. It will teach us how asteroids respond to touch, how momentum moves through rubble, how small actions ripple outward across years and orbits, and in doing so, it will give us something quietly profound: confidence. Confidence that we can guide a world with knowledge instead of force. Confidence that curiosity can protect as well as discover. Confidence that the sky above us is not unknown, it is understood, watched, and when needed, gently shaped. A careful investigator arriving in peace to understand a peaceful nudge. The future, shield of Earth, even as Dart and Hera teach us how to guide a wandering asteroid. Another quiet revolution is unfolding in the background, a shift from simply reacting to gently foreseeing. Because the greatest protection comes not from nudging a world, but from knowing it exists long before it ever nears us. Tonight we look ahead at the next generation of our Skyward Guardians instruments, designed to watch not just the bright, easy targets, but the darkest travelers drifting silently through the void. NEO-Surveyor, Earth's infrared lighthouse. Set to launch in the late 2020s, NASA's NEO-Surveyor will be unlike anything we've used before. A space telescope built not to study stars or galaxies or distant nebulae, but to search for asteroids we cannot see with ordinary light. It will watch the sky in infrared, the faint glow of heat that every warm object emits, whether it reflects sunlight or not. This matters because many asteroids, especially the darker ones, are nearly invisible in visible light. They are made of carbon-rich materials that absorb sunlight instead of reflecting it, making them appear as empty pieces of darkness against a dark background. But infrared light tells the truth gently. Even the darkest rock, if warmed by the sun, glows softly in infrared, a faint signature NEO-Surveyor will detect with ease. It is not a loud mission. No rockets chasing asteroids, no interceptors. Just a quiet telescope floating between Earth and Sun, watching heat where human eyes see nothing, closing the blind spots. From Earth's surface, there are regions of the sky we simply cannot observe, well areas lost in the sun's glare or hidden behind atmospheric haze. These blind spots can hide entire asteroids until they pass close by. Some approach from the sun's direction where our telescopes cannot look. Some drift through morning skies too bright to detect invisible light. Some move slowly and blend into the background. NEO-Surveyor changes this. From space it will see objects approaching from the sun's direction previously invisible to Earth-based telescopes. Dark asteroids, those that reflect almost no sunlight but still glow with warmth. Slow drifters whose faint heat signatures make them stand out against cold space. Dormant comets, cold black ancient wanderers, whose surfaces hide their origins but whose infrared warmth gives them away. Piece by piece it will fill in the map of nearby space until the blind spots fade and the unknown shrinks into clarity. The hidden travelers, dark comets and invisible rocks. Among the most mysterious objects NeoSurveyor is designed to find are dark comets, ancient bodies whose ices have long evaporated, leaving behind surfaces so black they reflect almost no light. In visible wavelengths, they are nearly invisible. They drift like shadows with mass. But infrared detection changes everything. Heat betrays them. Even a cold carbon-black comet retains warmth from sunlight, and that warmth glows softly in NeoSurveyor's detectors, a signature as distinct as a footprint in new snow. For the first time, we will see these objects not as threats, but as known wanderers catalogued, understood their paths mapped years or decades before they could ever come close. A shield built on knowing. When you imagine a planetary shield, you might picture something physical: walls, lasers, interceptors, technology drawn from fiction. But Earth's true shield won't be made of metal or force. It will be made of awareness. The quiet kind, the kind that comes from decades of observing, cataloguing, understanding even the faintest visitors. NeoSurveyor will find 2/3 or more of all medium-sized asteroids we have not yet discovered, objects large enough to matter locally yet small enough to be missed by traditional telescopes. When it does, we'll have a complete picture of our neighbourhood for the first time in history, a future without surprises. If the night sky once held mystery, soon it will hold knowledge, not all at once but slowly, patiently, as new telescopes join the quiet watch. Ground observatories, infrared satellites, ESA's FlyEye system, future radar networks, deep space survey missions. Together they will weave a net of awareness so wide and so sensitive that even the faintest traveller cannot slip through unseen. Not to frighten, not to warn, but to reassure. Because the more we see, the calmer the future becomes. A shield made of light. As you rest tonight, picture NeoSurveyor floating in silent sunlight, a telescope searching not for danger but for knowledge. It doesn't roar or rush. It simply looks patiently, with eyes tuned to warmth and darkness alike. And with every discovery, every faint glow, every invisible rock made visible, the shield around Earth quietly strengthens. Not a barrier, not a fortress, just awareness, just understanding, just light. A future where the sky is known, the blind spots are closed, and the universe feels a little less mysterious and a little more comforting. Stardust. Collecting the oldest dust. Before we leave the world of asteroids behind, there is one more kind of traveller, older, softer, more fragile, whose story gently threads into our own comet dust. Tiny grains that formed before Earth existed. Particles older than the sun. Fragments that drifted through the solar system for billions of years, untouched, unchanged, waiting for someone to reach out with a steady hand and bring them home. And so, humanity built a spacecraft whose mission was not to push, or guide, or protect, but simply to catch dust. A mission named Stardust, a name that sounded like a lullaby even before it left the Earth. Tonight we drift with it into the quiet world of aerogel comets and ancient grains of time. A spacecraft for a gentle task, Stardust launched in 1999, a small light spacecraft with one extraordinary instrument, a tray filled with a pale blue substance that looked like frozen smoke, weighed almost nothing, and held the softness of snowdrift aerogel. It was the perfect catcher's mitt for material so old and so fragile that a solid surface would have shattered it instantly. Stardust didn't need drills or arms, it didn't need force. It only needed to pass quietly through the thin veil of dust shed by a comet, and let the aerogel do what it does best, slow something gently without breaking it. Aerogel, the softest solid ever made. Aerogel is one of the strangest materials ever created by human hands. It is 99.8% empty space, lighter than a feather, almost transparent, delicate as frost, yet able to stop a particle moving faster than a bullet. It works through tenderness, not strength. When a dust grain hits it, instead of colliding, it sinks, burrowing slowly into the maze of silica strands that make up the gel's invisible framework. The particle carves a glowing comet-like trail through the aerogel, a tiny tunnel that preserves its path and protects its structure like a fossil captured at the speed of light. It is physics as poetry, a material so gentle that it can cradle stardust that has been untouched since the dawn of the solar system. Toward Comet Wild 2, a visitor in the dark. Stardust's destination was Comet Wild 2, a small, icy traveller that had spent most of its existence in the cold outer reaches of the solar system. Only recently had Jupiter's gravity nudged it inward, allowing a spacecraft to meet it for the first time. As Stardust approached in 2004, Wild 2 released dust grains from its surface fragments, from its frozen heart particles older than oceans, forests, and every stone on Earth. The spacecraft passed through the dust stream with slow, patient confidence, its aerogel panels open like soft blue wings. Dust struck the gel and settled into it like seeds into snow. No violence, no cracks, only silent capture grains of time coming to rest in a cradle of the air, a soft harvest of the ancient. When the dust collection was complete, the aerogel trays were sealed inside a small return capsule, a conical vessel designed to protect its fragile treasure. Inside that capsule lay particles older than the planets, minerals formed in the earliest nebula, organic molecules that may have drifted through space for billions of years, grains that witnessed the birth of the sun, and then, as gently as it had collected them, Stardust turned for home. Coming home, a safe return, through fire. On January 15, 2006, the return capsule re-entered Earth's atmosphere, a brief bright streak over the Utah desert. Inside, the oldest dust in the solar system remained perfectly safe. When scientists opened the capsule, they found the aerogel etched with tiny glowing tracks, each one the mark of a particle that had travelled billions of kilometres and billions of years to come to rest in a material as light as dreams. These fragments held secrets of our earliest chemistry, our earliest minerals, our earliest possibilities. They were whispers from before there was an Earth, before oceans formed, before the moon existed. Whispers caught in a net of frozen smoke. Why Stardust matters in a story of planetary safety. Stardust was not a defensive mission. It did not push or pull or guard against danger, but it taught us something essential, something deeply calming. The more we understand the oldest objects in the solar system, the better we understand their paths, behaviours, and histories. Comets and asteroids are storytellers, and Stardust helped us listen to them. Every particle it returned was a clue, a piece of a puzzle that helps us predict the future motions of the ancient bodies that share our solar neighbourhood. Knowledge is the quietest and strongest shield of all, the dreamlike legacy. As you drift towards sleep, imagine a tiny grain older than mountains, older than Earth itself, floating in darkness for billions of years, until one day it settles gently into a transparent cloud of aerogel. Imagine its long journey ending not with force but with softness. Stardust taught us that even the oldest, most fragile things can be held safely if we meet them with the right touch. A spacecraft catching ancient dust, a material made of air, a story billions of years old preserved in silence. A reminder that sometimes the universe reveals its secrets only when we learn to listen softly. Deep impact. Learning by touch. Before DART ever nudged Dimorphos, before Hera was even imagined, there was another mission, one that reached out to a comet not to change its path, but simply to learn what happens when a small world is touched. A mission called Deep Impact. Its name sounded dramatic, but the truth of the encounter was quiet, controlled, and deeply scientific. It was the first time humanity gently tapped a comet's surface to see what lay beneath a calm, deliberate experiment that unfolded like a slow exhale in the darkness of space. A comet older than Earth. The destination was Comet Tempel 1, a 6-kilometre-wide traveller drifting in a long looping orbit around the Sun. Comets are among the oldest bodies in the solar system. Icy, dusty, fragile worlds that still hold the chemistry of our earliest beginnings. By reaching Tempel 1, scientists hope to glimpse that original material to understand how planets form, how water arrived on Earth, how the early solar system shaped itself millions of years before life appeared. But comets do not give up their secrets easily. Their surfaces are delicate, covered in dust, crinkled by heat, patched by ancient eruptions of gas and ice. To learn what was beneath, we needed a gentle touch. The impactor, a slow, soft collision. Deep Impact carried two main pieces, the flyby spacecraft. The impactor, a small copper probe designed to strike the comet like a fingertip pressing into soft snow. This was no explosive device. There was no detonation, no attempt to shatter or disrupt. The impactor simply allowed gravity to guide it into the comet at a steady, predictable speed. A controlled collision meant to produce a cloud of dust and ice that could be studied from afar. In the early hours of July 4, 2005, Tempel 1 drifted into view, a rugged, shadowed world turning slowly against the void. The impactor approached, sent its final images home, and then a quiet flare of light. Dust rising. Material lifted from darkness. A smooth, pale plume billowing outward like powder brushed from an ancient book. A cloud. Too beautiful for clarity. For a moment, scientists expected to see the crater, a modest hollow etched into the comet's soft surface. But the dust cloud was enormous, much larger and brighter than anyone had predicted. It reflected sunlight like fresh snow, glittering in the dark as it expanded gently away from the comet. Instead of revealing a crater, it hid it, a beautiful shimmering curtain obscuring the very feature Deep Impact had tried to observe. The moment became a paradox. The mission succeeded perfectly, yet the result was visually hidden behind beauty. The flyby spacecraft captured everything it could. Plume's arcs, the gentle trajectory of particles rising from the surface, but the crater itself remained unseen, a mystery left for another day. The need for a second visit. Scientists realized that Tempel 1 had more stories to share, stories still wrapped in dust and shadow. The only way to see the crater and truly understand how the comet's surface responded was to return. And so, in a twist of fate, rare in space exploration, a spacecraft that had already completed its original mission was reassigned a new one. The Stardust spacecraft, now drifting quietly in deep space after returning comet dust to Earth, was sent back out to meet Tempel 1. This extended mission became Stardust Next, a gentle encore, a second chance to see what Deep Impact had revealed but concealed. A lesson in patience, Deep Impact taught us that touching a small world creates beauty. Spiraling dust, glittering plumes, soft veils of ancient material, but not always clarity. It taught us that learning from the cosmos requires patience, return journeys, and a willingness to revisit a place with new eyes and new tools. It also showed us how comets respond to touch, not with violent reactions, but with soft releases of dust and ice, as if exhaling after a long silence, a prelude to what comes next. Deep Impact was a beginning, the first gentle tap on a small world to see how it behaves. The obscured crater set the stage for Stardust Next's return, and together these missions gave scientists their first detailed picture of how fragile worlds react to a controlled encounter. Not with chaos, not with destruction, but with delicate change. Dust lifted, material revealed the surface subtly altered by a single thoughtful touch. As you drift towards sleep, imagine that dust cloud again, soft, bright, slowly drifting away from a silent comet, a veil of ancient particles rising like breath in the coldest corner of the night. A reminder that learning often begins not with answers, but with beauty. Stardust, next returning to an old friend 6 years past. 6 slow, wandering years during which a small spacecraft drifted quietly through the solar wind, unhurried, untroubled, moving along its gentle looping path around the sun. The mission that had once defined Stardust was already complete. Its sample capsule had returned to Earth. Its aerogel collectors were empty. Its story, by all normal measures, should have ended. And yet, in the quiet dark between worlds, Stardust still had a little fuel, a little life, a little purpose waiting to be rediscovered. When scientists realized that the crater left by Deep Impact remained unseen, hidden behind its own beautiful plume, they turned to the spacecraft already wandering nearby. A spacecraft with time, with patience, and with a gentle heart. Thus began a new chapter, Stardust Next, the return to an old friend. A long journey back. The path back to Tempel 1 was not straightforward. Stardust took a 6-year arc through the inner solar system, looping past the Sun, past Earth again for a gravity assist, and out toward the comet it had never been meant to revisit. But that was the nature of the mission now, not urgent, not dramatic, just a quiet return, a kind of celestial reunion. As Stardust approached, Tempel 1 appeared like an old mountain rising from mist, familiar in its outline yet touched by time. This was a world that had lived through an entire orbit around the Sun since humanity last visited. One full cycle of heating and cooling, of quiet jets and drifting dust. The comet had aged subtly, softly, and Stardust in its second encounter would see it all. Finding the crater at last. On February 14th, 2011, a gentle symbolic date, Stardust glided past Tempel 1 and turned its cameras toward the surface. What Deep Impact had obscured was finally revealed. There it was a shallow, soft-edged crater about 150 meters across, resting like a thumbprint pressed into powdered snow. Not violent, not jagged, just a broad depression, a record of a gentle touch that had stirred the comet's surface 6 years before. Seeing it felt almost emotional, as if peeking into a memory long overdue. The crater told scientists that Temple 1 was fluffy, porous, a world made of fragile materials loosely held together, the kind that shift rather than shatter. Deep impact had not broken the comet, it had simply rearranged it, an aging landscape. As Stardust continued its flyby, it became clear that Temple 1 was not the same world Deep Impact had photographed. Some areas had changed in quiet geological ways. A ridge had retreated, eroded by jets of escaping gas. 3 pits had softened into one, their edges blended by seasonal activity. Dust had shifted across the surface, leaving new patterns of brightness and shadow. These weren't violent changes. They were the gradual breath of a comet's life surface, ice warming, sublimating, refreezing, carrying tiny grains with it. Temple 1 was aging in the gentlest way imaginable, a world shaped by sunlight and silence. And Stardust, like a friend returning after many years, noticed every detail. A reunion in quiet light. There was something deeply human about this moment. A spacecraft, long past its prime, met a comet it had known before and learned how time had touched it. It felt like visiting an old childhood place. The same contours are there, but softened, shifted, changed by years you cannot see but can feel. Stardust's images captured that sense of passage, not dramatic transformation, but gentle evolution of a landscape that drifts through darkness at its own unhurried pace. The final farewell. After the flyby, Stardust used the last of its remaining fuel to test its thrusters, measure its reserves, and help future missions understand how spacecraft age. Then, in a final whisper across the void, it sent its last message home, a soft acknowledgement that its long journey had come to an end. The spacecraft now rests in a quiet orbit around the Sun, a small monument to patience, curiosity, and the beauty of returning to a place after time has passed. A soft reflection on time. As you let your thoughts settle, imagine that slow reunion, a silent spacecraft approaching an old friend, seeing familiar shapes changed by years, and recording them in calm, steady light. Temple 1 continues its wandering. Stardust continues its drifting. Both now share a gentle moment in history, a reminder that even in the cold depths of the solar system, time moves softly and landscapes age with quiet grace. A story etched not in stone but in dust, light, and memory. Lessons from fire and ice. In the long, quiet arc of our solar system, comets drift like wandering archives, carrying pieces of stories older than Earth itself. Some are gentle, icy travelers. Some are relics of fire born in the white-hot cradle of the young sun. And when we study them closely, we begin to see how the ingredients for life were stitched together across time and distance. The missions you've heard about, Stardust, Deep Impact, Stardust Next, were more than engineering triumphs. They were moments where humanity reached out into the dark and touched the ancient materials that shaped our world. And from those touches, soft, patient, careful, came lessons written in both fire and ice. Ice that holds the oldest. Dust, Stardust's aerogel, captured grains no bigger than sand, tiny flecks of cometary material that had wandered untouched for billions of years. Inside those grains were minerals forged in unimaginably hot environments. Calcium aluminum inclusions particles that could only form near the newborn sun, where temperatures soared high enough to melt stone. It was a reminder that comets are not merely frozen leftovers. They are mosaics, pieces of the early solar system mixed together, carried outward, preserved in ice. Fire and ice woven into the same body. Dust that carries organic secrets. When Stardust samples were brought home and opened under laboratory lights, scientists found something quietly astonishing. Among the minerals and glassy grains, glycine, an amino acid, the simplest building block of proteins. Not life itself, not a whisper of biology, but the letters from which biology writes its words. Glycine can form in the cold dark between the stars or within icy bodies as radiation gently alters simple molecules, and then comets on long drifting paths can deliver these fragile molecules to the surfaces of young planets. Not as sparks of instant life, but as seeds scattered softly across a world still learning how to become habitable. A story older than Earth comets remind us that the chemistry of life is not confined to Earth. It is scattered through the cosmos, in dust clouds, in icy nuclei, in particles drifting between planets. We are not separate from the material of the universe. We are part of it, built from elements that formed in stars assembled in space and delivered by wandering debris over eons. The water you drink may have once been locked inside a comet's ice. The carbon in your body may have travelled in a dust grain across ancient space. The atoms in your cells were forged in places of heat no living thing could ever endure. Life is not an accident isolated on one world. It is a continuation, a long chemical conversation between fire and ice, stars and planets, time and possibility. A soft, cosmic truth. As you breathe slowly, let this thought settle. We are in a quiet and literal way citizens of the cosmos. Our bodies hold atoms that have travelled farther than any spacecraft. Our oceans may carry the memory of cometary ice. Our proteins contain the same building blocks found drifting in space. The universe did not simply create a world for us, it participated piece by ancient piece in making us. And in every comet we study, we find another fragment of that immense story, a reminder that life is stitched together from both the heat of creation and the cold of drifting worlds. A story written in fire and ice, waiting quietly for someone to read it. A good night under a safe sky, and now, as we drift toward the end of our journey, the sky above feels a little different. Not darker, not more mysterious, but gentler. A place where danger has slowly transformed into understanding. For the first time in human history, we are learning how to shield our world. Softly, methodically, one mission at a time. Dart showed that a small nudge can move a world. Hera will teach us how that nudge travels through rock and dust. Neo-Surveyor will watch the hidden corners, the blind spots where dark comets might once have passed unnoticed. Piece by piece, a quiet planetary shield is beginning to take shape. Not a wall, not a weapon, just knowledge, skill, and the calm confidence that comes from finally looking outward with clear, patient eyes, turning danger into wonder. Asteroids, comets, falling dust for most of human history. These were omens, flickers of fear crossing the night sky. But tonight you can think of them differently. The tiny bits of dust that burn up overhead are simply ancient travellers coming home to the atmosphere. The comets with long, glowing tails are messengers from the solar system's youth. The larger objects, rare, distant, reliably tracked, are no longer shadows to worry about, but worlds we watch with curiosity, and worlds we now know how to gently move aside if we ever need to. The cosmos has not grown safer, we have grown wiser, and with wisdom comes a deeper, quieter peace, a safe sky to sleep beneath. As you settle into stillness, imagine the Earth turning softly under that wide star-pinkled dome. Imagine the silent watchers, ground telescopes, space probes, infrared eyes drifting in orbit, all keeping gentle track of the things that wander between worlds. Imagine a sky that is no longer unknown but understood. A sky that once held fear, now filled with wonder, steady, serene, and watched over with care. You can rest beneath that sky as countless people have before you, but with one added comfort: we are learning how to protect our fragile blue home. We are no longer passive passengers in the cosmic night. We are participants, curious, thoughtful, and quietly prepared. Good night. So let the stars soften into a gentle blur. Let the slow turning of the earth rock you into calm. Let your breath fall into rhythm with the quiet hum of the universe. You are safe. You are small in the best possible way. And above you stretches a sky that humanity now watches, understands, and cares for. Drift peacefully into sleep tonight under a protected, peaceful, ever-watching sky.